Hi, and welcome to episode 22 of this ChessTDD codecast. I got right down to the point here when I was doing this the other day, and I said I wanted to pick up where I'd left off and deleted a test, and I wanted to implement this concept of blocking for the knight. So what's going on right now is if you try to move one space ahead and then two spaces over with the knight from the white side, it will the board will return that as a valid move for you, even though there's a pawn there, and the knight actually can't do that because it's not capturing a pawn and it's not an empty square, so you can't put a piece there. So this is going to be relatively straightforward. I'm going to say that let's assert false that this move exists in the ones that are returned, and we know from last time that's going to be red, so now let's make it go green. What I did, and it proved to be kind of interesting here, as you'll see, I started with something that I thought would make this test go green, but I wasn't really sure. This has been a particularly long gap because I've been actually wrapping up my most recent Pluralsight course. So that's been nice to get that done with, but it's sort of made me ignore this a little bit. So long story short, it had been a while since I looked at this, and I just sort of assumed that things would go red here. They didn't. That's not great. That means, as one might expect from spending several weeks away from the code, I didn't know what my code was doing exactly. And it's all well and good for this to work and this test to go green, but one thing that I find is when this scenario happens, when I'm expecting to break a bunch of older tests and I don't, and when that tells me that I'm not really knowing what my code is doing at build time without running it, a common misconception of the TDD approach says that in this case, that's fine, whatever, it doesn't matter as long as the tests go green. That's not true. This whole process is designed so that you understand at compile time what your code is doing. So what I need to do now is say, okay, why did I think that was all going to go red? And why didn't it? So let me kind of think through what I thought would break and then write some more tests around that to expand my understanding. It's just sort of the same thing as looking at your code and just sort of reasoning through it, staring at it, maybe drawing on a whiteboard, except when you do it this way, you wind up with tests. And you should leave those tests assuming that they're actually meaningful tests of functionality and not just interim things that you're doing. So I'm soldiering on here, and I'm hoping, or I was hoping when I wrote this, that kind of writing a few more tests and seeing how this would go would refresh my memory to some degree. So I'm saying, okay, I have written a failing test and then made it pass for the case of not being able to move to a friendly square, but what I should do now is I need to be able to capture a piece. So I should, in this empty chessboard where there's no pawns, or I shouldn't say empty, but pawnless chessboard where it's just each side first row. Now, if I move my rook all the way over to my opponent's rook in the last square, I should be able to do that. That should be flagged as a move that I can make. So now I'm in the process here of, okay, so how do I actually write that test? This is a new thing. Because what I'm saying is in some cases, I can move to where there is a piece, and in other cases, I cannot. So I have to do something. So I'm going to introduce this concept into the board class in a private method of a friendly piece versus just a any piece, because right now there's no distinction. So what I tried to do here was, frankly, get a little too cute. I wanted to get a green test and then start writing maybe more tests around this concept. So I said, let's return true if this matches 1, 8. So basically, you see what I'm doing here. I'm going to hard code in like, oh, well, does friendly piece exist at returns true if I'm trying to move to this particular space? Now I saw that, okay, I think that probably made the test I just wrote pass, but it's breaking others. And then I started throwing in, maybe I wasn't thinking this through properly, so I negated it, and then that made 9 tests go red. And so I kind of scratched my head for a second here and then said, you know what, forget it. And this is what I'd like to think of as kind of getting a little bit too clever. I was getting cute here. I thought that I could put in a placeholder. Hey, this will be great. I'll just get everything green and then I'll figure more out later. But as you might expect from basing this on maybe not the greatest understanding of what I've been doing a few weeks ago, that didn't work out real well. So what I decided to do is I'm going to start by just having this method be a wraparound does piece exist at. And that's a good starting place because does friendly piece exist at is going to depend on whether a piece exists in the first place or not. So this has two conceptual parts. I'll find out if a piece exists. And then if a piece exists, I'll determine whether it's a friendly piece or not. Pretty simple and better than making up cutesy half measures to get a green test. So at least better in terms of advancing toward functionality. So one of the things to take away from this is I've been doing this for a long time. I have a lot of practice with it, but no matter how long you've been doing it, you're going to have some false starts or go down some blind alleys or what have you when trying to figure out how to go green with your current test and not break anything else. That'll never go away. You'll just kind of get better at recovering from it, so to speak. And it'll probably happen less often as you practice. I used to mess this up a lot more than I do now, so I'm, I guess, getting less bad at it. So what I'm doing here now is introducing this is a first player piece concept, and it doesn't exist, so I have my test continues to fail, this time by non-compiling. So I'm going to declare this property in the piece class, and it's going to be a bool. And that's really kind of all there's going to be to it. Is this a white piece or a black piece? But I didn't want to give it that terminology because you see some chessboards out there that are like wood and ivory or whatever. There's no strict reason that they would always be black and white. So I think of them as first player or other, second player, whatever. So what I'm doing in here is taking advantage of C-sharp's optional parameters. Probably done this before in this series. As of, I think, .NET 4, you could do this. I like this construct a lot. It's a nice way to introduce an argument without breaking existing code. So this is backwards compatible. Basically, I've just never distinguished whether this is a white piece or a black piece before, or a first player. I guess I should use the same terminology as myself. I've never made this distinction before. So the reason that I'm going to default to true is because I know that the overwhelming majority of the tests that I've written started out at least with the assumption that you were the first player. Eventually, I started introducing pieces on the opposite side of the board. But I think the good default here, just based on what all of my old tests are doing, is to say, unless otherwise specified, create a piece that's a first player piece. So what I'm going to do here, and now I have additional red tests, or no, I still have the one red test. I've just never gotten it green. So I've been non-compiling for a while. What I'm doing is I'm introducing, and it's a little laborious, I'm introducing this on all the inheritors of piece. So every piece is going to understand whether it's a first player piece or not. And the annoying part about this is that due to the combination of not having a refactoring tool that will let me kind of push that method down into the classes, at least that I know of, and by C# wanting me to specifically declare this constructor in all the child classes, what you're seeing me do is engage in this sort of a tedious operation. Another thing that I'll mention here that I don't do in this series, because it would be sort of weird and boring for you, but that I would do if this were just me developing, I tend to let myself get sidetracked at times, where I might go out and scour the internet for a way to actually, when I'm putting a constructor like that in a base class, to drive it down to the child classes. That's the kind of yak shaving that I tend to give into. And I don't view that as typically being a problem because I do it on my own time a lot, so to speak. So if I sidetrack myself for 2 hours during the workday on something like that, it's not a great use of either an employer's time or a client's time or whoever. So it's not that I don't do it. I see value in it. I just, put in extra work later, or maybe I do the yak shaving type activities after hours or something. It's a bit of editorializing, but it's doing stuff like that. Being in that habit is a good way to advance your career. It's not for everybody. I'm not advocating that you work 12-hour days or anything like that, but it was definitely a way that I got a leg up, so to speak. I learned a lot of stuff by not limiting myself while also, doing kind of the ethically right thing, in my opinion, and not teaching myself IDE tricks and whatnot on somebody else's dime. So anyway, back to what's going on here. I had to fill in the time here somehow because this is fairly boring. That's kind of you're not necessarily getting a taste for how I would actually behave if I were just writing code in a vacuum. Or I should say writing code in my day-to-day life. I actually would kind of chase down these things and try to get to know what I was doing a little bit better. Might be that there's no solution out there. Might be that CodeRush does it and I don't know how. Who knows? If anybody knows, that would be interesting information for me. I'd love the learning if you could provide it in the comments. So now what I have here is a concept of first and second player. So in this setup method, I'm going in here and saying, okay, when you create these pieces on the 8th coordinate, that's going to be player 2, and I've got these player 1 pieces. So now this does friendly piece exist at is going to say, is there a piece there? And is the piece at the destination of the same player as the piece at the origin? Meaning this would be a friendly move that you wouldn't allow. So now, why is this still red? That's interesting. I'm returning all possible moves where it's not blocked and there's not a friendly piece. And then I kind of remembered that I was how this implementation was actually working and what it looked like in the isBlocked method, how I was kind of generating radially outward these paths, but the path didn't include the destination. So I made a correction there. I moved that down into the isBlocked method, and then I realized, oh, okay, so, man, this is another thing to note too. It's important to pay attention if you're using a tool like nCrunch. It's not immediately obvious, but I actually got my, with that move down into the isBlocked method, I got the tests to go green that I had just written, but I introduced a regression bug. And basically that's because nothing in the method that I was using of that is first player piece had forced me to do this for pawns, because you remember the test scenario that I had been considering had no pawns. So because I didn't because I preserved backwards compatibility, I was creating this scenario that I'm correcting here where I'm putting friendly pieces in the way, or at least that was what was going on with that last test. With this one, I think there's a similar kind of thing going on that I'm not. Oh no, this is a legitimate break, and unfortunately, I recorded this about 3 or 4 days ago, so I'm trying to remember exactly what was happening here. I think that I need in both places, the isBlocked, and then I also need to, so isBlocked will determine if at any point along the path I'm hitting a friendly piece, but because of what I had said earlier, which is that isBlocked was only getting the moves up to your destination, not your actual destination, I also have to say, okay, I have to make sure that we're accounting for the last move, and that makes everything go green. So all possible moves sees if anything in the middle is blocked, but then I'm also saying, okay, is it blocked, and is this last thing a friendly piece? This is fairly awkward, but it's working, so that's kind of your trade-off. In terms of reasoning about this at compile time, I have a pretty good handle on what it's doing. The problem is what it's doing is sort of unintuitive, so that's going to be a good source of coming back and doing some refactoring. Another thing you'll notice as I'm going here is that, let me see, I think I wrote another test that I got failing. Oh, so this was kind of like, I was taking into account the idea that there might be a friendly piece at the destination only, but what if there are two friendly pieces? So the code I have in place now, let me put a finer example to this. Say I have a rook with nothing in front of it, and my opponent has a pawn and then a rook behind it. I stopped him from allowing movement onto the pawn, But my hypothesis when I was writing this this test method, should not allow rook at 1-1 to capture at 1-8 when there's a pawn in front of it. So I wouldn't be able to move to 1-7 where the pawn is because of the implementation I just made. But I realized I don't think this is going to actually stop me from jumping the pawn, so to speak. So I'm writing a test to see if that's in fact the case. And that was just for add piece, so don't panic. I'm still, I think, properly reasoning about this. So if I get the moves, I want to assert that I can't move to that 1-8 rook. I can't go jump over the pawn with the rook. And so this was, I think I scratched my head a minute here as I was writing it. What I realized that I wasn't doing was kind of accounting for, I'm going to search for each piece along the path. And then if I hit a friendly piece or if I hit an enemy piece, there's something different that goes on. So if I hit a friendly piece, I'm done. I'm blocked. I shouldn't consider anything past it. If I hit an enemy piece, I can move to that one place, but I can't move anywhere beyond it. So this does friendly piece exist at. What I'm not doing here in considering whether something is blocked is understanding the concept of a last space. So you'll see kind of what I want to do is I want to get all the spaces along the path that I could check. And I want to say that, okay, if there is a friendly piece anywhere along the path, I can't move there. And if there is an enemy piece along the path, I should also be blocked, unless the enemy piece is in the last space, I believe is how I reason through this. Again, this is not overly intuitive, and I'm building up correct test cases, but the implementation is awkward. And you'll notice also that I'm doing things here like, so I'm going to create this path maker. I'm going to get all the spaces along the path. Then I'm going to get the last one. And I'm not sure really how this is performing. Probably poorly. I would be surprised if at some point I weren't reiterating over the same enumeration that I had already iterated over. But I got to be honest, I don't much care about that. It's not just because this is sort of a toy example application. I generally don't care about performance until I have some requirement. If there's some customer screaming at me or if I'm failing to meet some condition that's been laid out. Because, in this type of code, it really doesn't matter. I mean, you're probably talking like microseconds. This is all going on in memory. But even if not, and even if it's in production code somewhere, it's just, you write a lot of bad code when you worry about performance, in my experience. You can always clean up in terms of performance. So you can write really nice looking, easily understandable code that doesn't perform well. It's easy to go back and say, okay, we need to optimize this. It gets really hard to go the other way and say, okay, I've got this code that's really fast, but I have no idea what it's doing. Making that code look clean is really hard. So there is work to be done. I don't view this as an acceptable final state, but it is making my test pass, which is, what we need for the time being, so long as you have the caveat that you're going to come back and clean things up. So now I'm kind of taking care with the board. So I've implemented this blocking concept, and I'm sort of going in here and prioritizing a little bit. I want to make this more readable. I want to get my head around it better. So that's the things I don't like at the top. Some of this other stuff, I am gravitating towards some of the cleanup that I haven't addressed in a bunch of episodes. I'm going to put and say I'll worry about it later. I want to start maybe getting some acceptance tests around this, some real life scenarios. And I want to start focusing more on correctness. I'm sort of taking the approach that this would be like production implementation, and maybe it's time to actually start getting something out there and worrying about making it beautiful later. So that's kind of where I think I'd like to drive this in upcoming episodes, to start writing some integration tests, acceptance test type things that aren't just unit tests, and maybe I'll go onto the internet and find examples of actual games and actual series of moves available to a piece, and then start creating those in this code base to say, okay, well, in this particular game that Bobby Fischer was playing against Boris Spassky in this, set of whatever, he could have done the following things with his knight, and I should write a test case that verifies that I'm returning the same set. So I'm also committing things in the GitHub repository here. I feel like maybe I ought to be showing that, like, because it is the normal way I develop things. I've been leaving that off. Doesn't take a whole lot of extra time. So anyway, that's about it. I'll see you next time, where I think I'm going to look at tackling these acceptance tests and writing integration tests, that sort of thing, driving functionality that way. So have a good one, and I'll catch you next time.